We will be following our social media channels and conversations on that all day. And we are just seconds away from kicking off with Larry Maccherone here from Comcast. Larry and Mark and I have met on different occasions over the last couple of months. Larry was at our Nexus DevSecOps leadership forums in Washington, D.C. I know he and Mark also met out in San Francisco a couple of months ago at RSA when we were doing the DevSecOps days, the first DevSecOps days, where we had about 900 people there. So we've got about 1,500 people registered for today's conference, and we're all set to kick it off. And while we're on Eastern time, Larry is on Pacific time in Las Vegas. So he woke up early morning to join all of us.
My first question is, did you get tickets for tonight's game? That's the real. Are you a hockey fan?
Not a hockey fan.
Hold on here. We're not getting some audio from you, Larry. Let me just make sure that we're okay. You need to turn yours off. All right. That was on our end, not yours. Good.
Can you hear me now?
Yeah, you're doing great.
Doing great. Okay, cool. So yeah, no, there's lots of T-shirts around town. It's a big deal here, but not a hockey fan myself. So.
All right. Then Derek's going to slip out. I'm going to go on mute here, and we're going to turn it over to you. And we'll see you back here in about 25 minutes.
Okay, sounds great. Okay, so let's get started here. DevSecOps is not just DevOps lipstick on a traditional security pig. That's the title, the full title of this talk. I think we shortened it to just DevSecOps is not lipstick on a pig for the purposes of this conference, at least for the agenda for the conference. So what I'm talking about here is the fact that a lot of folks who are in the industry with frameworks or with tools, particularly for traditional security practices, which are mostly targeted at the security specialist groups at large organizations. That's their big customer base. Those folks are labeling their traditional tool or their traditional framework as DevSecOps without actually achieving any of the vision or accomplishing any of the goals of DevOps. And so what I'm going to talk about here today is a set of principles and concepts that apply to both tools, but also apply to culture and process. And I'm going to start with the culture and process because the rest of the day you're probably going to hear about lots of tools. I'm going to end with tools, and that'll be sort of an introduction to the rest of the day for you here. Before I get too much into this, though, a little bit about my background. Graduated from Virginia Tech with electrical and computer engineering degree. Started my first business while I was still an undergrad at Tech. So if there's any Hokies in the fans here, so go Hokies. I grew that business to 80 employees, 20 million a year in sales. Our biggest customer was GE Power Generation. We wrote the software that controlled the power generators. So if there was a vulnerability that bad guys could exploit in that, it would be really bad. GE had about 60% market share at the time of the world's power controllers. So turbine controllers. So we would have basically exposed 60% of the world's power grid to attack. So we got really, really good at writing software with very high quality, very low vulnerabilities. That got noticed by some folks at Carnegie Mellon who were launching this thing called the SciLab. In addition to the Carnegie Mellon already hosts the CERT and the SEI, the Software Engineering Institute. So they asked me to come to Carnegie Mellon to help them launch this new program. I was the executive director of the SciLab when it started. And while I was there, I met up with a woman by the name of Nooper Davis, who's now Comcast's Chief Information Security Officer. And Nooper and I, together with another gentleman named Gary McGraw, who's now at Cigital. Cigital was sold out to another vendor. We launched a program called the Build Security In initiative with the Department of Homeland Security. I went to Carnegie Mellon because I wanted to change the world and literally change the way development gets done so that it was more secure. And with this basically this concept of practices and principles that was fundamentally different from the way it had been done before. I found that I really couldn't change the world very effectively from academia. So I left Carnegie Mellon, went to go work for Rally Software. And the reason I did that is Rally has this database of tens of thousands of teams worth of data. And I thought that if I could prove out my framework with that data, then I could literally change the world, which is what I set out to do. And I pretty much did that. I published the largest ever study correlating practices, everything like iteration length to pair programming to specific security practices. I correlated those with performance, productivity, predictability, quality, responsiveness. And that's sort of how I'm known in the industry, as having published that big study. I'm still an active developer. I have a dozen or so open source projects, one of which gets over 200,000 downloads a month. And I feel it's really important that if you are trying to change the behavior of developers, that you actually be an active developer yourself. It's very hard for them to listen to you if you're not. So let's get into the principles and the concepts that I'm trying to introduce here now. So the basic problem is that bolt-on security by security specialists will not scale. So you just can't have enough security specialists in your organization to actually keep up with the pace of software development. DevOps makes this much worse, makes it an order of magnitude worse. And the security specialists have no idea what to do with the fact that teams are actually pushing to production multiple times a day. They used to think of themselves as a gating function. In fact, a lot of them still do. And they don't know, even the ones that realize they are no longer effective as a gating function to production, don't really know how to do it, don't really know how to help. And this talk is essentially a way for security specialist groups to transition into a different way of thinking that's much more aligned with DevOps. So the primary idea here is that the development team takes the primary responsibility for making sure that the product is okay to ship to production. That's what happens with quality now. It didn't always, but we're proposing that it happen with security going forward. So this is my favorite definition of DevOps or DevSecOps. I tend to think of DevSecOps as a marketing term, and it's really DevOps, but with the sec added, you're just sort of emphasizing the security aspects of it. But it's empowered engineering teams taking ownership of how their product performs in production, including security. And this is not the only definition that I like. There's a tools-oriented definition. There's a culture-oriented definition. This is the one that just sort of fits my framework the most. At different times, I'll refer to other folks. I'm not proposing this as the one, though. Please make sure that you don't confuse that. This is my DevOps continuum, and everyone uses an infinity loop to describe DevOps, so I have my own sort of flavor of this infinity loop. And I've grafted over the top of it a list of about 30 practices or so that you can do at various points in this continuum. And I don't have time in this 30-minute talk to walk through each of these one at a time, but they basically go through the whole life cycle one at a time. There is one that I want to stop at here and talk about for just a minute because I think it's really key to understanding the rest of the framework that I've got here. And that's this analyze and learn step. I have this thing called the defect or incident or vulnerability 3-step. And basically what it says is that we should stop thinking about defects being found or vulnerabilities being found or incidents as just an emergency you need to fix right away. It is that. Let's admit that. But it's not just that. So when you get a defect or a vulnerability or an incident like that, you should obviously fix that defect. That's step one in the 3-step. But you should also then basically try to abstract a pattern out of that and look for other places in your existing application or other applications that match that pattern and fix those. So that's step 2. And then step 3 is put in place something that will prevent you from ever introducing something like this in the future. And this is usually a tool in our space, something that would automatically look for certain types of vulnerabilities that gets run continuously. Or maybe you already have a tool like that. You have to configure it to look for this particular type of tool. Sometimes it can be training. Sometimes it can just be a process change. Sometimes it can be a wholesale technology change. So buffer overflows are much harder to do in Java than in C, C++. So if that's your problem, then maybe switch to Java. It's a long-term decision, but that's the 3 steps. The third step is usually the longest, takes the most time to actually accomplish. So this is the whole list here. Print this out, hang this up on your wall. I don't know how slides will be available, but if you reach out to me on LinkedIn, and I think my LinkedIn is at the bottom of some of these pages, I'll be glad to send anyone my slides here from today. So that's a lot of stuff. How do we get engineering teams to actually do this stuff? A lot of that stuff might be geared more towards ops teams or might be geared towards more security specialist teams. What I'm trying to do is to get development teams to take ownership of it. How do you get them to take ownership of it? Well, I have this 3-part framework that I've used in the past. I used it in the Agile world. I used it to transition teams to DevOps. I use the framework now, and I'm using it at Comcast heavily to transition teams into DevSecOps to take on the security aspect of this work. The framework is basically 3 steps, 3 parts, but the details change in those 3 different contexts that I just described: Agile, basic DevOps, DevSecOps. But we're going to talk about this one in the specific concept of DevSecOps. But the first step in the general framework is win the hearts and minds of the people who you're trying to change, in this case, developers. There's a big problem here, especially for security teams at large organizations, because there's a huge lack of trust between dev teams and security teams. It goes something like this. The dev teams are think security, they're nothing but a hindrance. They just get in our way, or they give us lots of work and they never seem to help. So we don't really like them, and they don't understand where we're coming from. The security folks think, oh, those dev teams, they can't be trusted to do anything. We have to watch them like a hawk. So there's this huge lack of trust, and breaking down that barrier is key to making this work. So I have 3 sort of tools, so to speak, to help break down that barrier. One is this thing that I've sort of grandiosely described as the DevSecOps manifesto. You can think of it as a set of core principles here. And the first one is build security in more than bolt it on. We've already talked about that a little bit. Note the structure of each of these bullets in this principles manifesto here is something more than something else. That doesn't mean that the thing that's after the more than is not valuable. It just means that the thing that's before the more than is what we're emphasizing, that we think is more valuable, at least for this conversation in this context. So build it in by the engineering teams rather than be bolted on after the fact by security specialists. Rely on empowered engineering teams more than security specialists. Implement features securely more than security features. When you say security to a developer, there's sort of a very narrow scope of things that pop into his head. He thinks authentication, authorization, encryption. But the bad guys don't necessarily tack only those aspects of your application. In fact, they're much more likely to use any input field. The input fields, the regular features that have to be there for your product to do what it was intended to do, that's what they'll attack. Not necessarily just authentication, authorization, and encryption. And so you have to actually work on making sure that everything you write is free of vulnerabilities. Rely on continuous learning more than end-of-phase gates. That's exactly what I was talking about on the continuum there with the 3-step. And build on culture change more than policy enforcement. Policy enforcement is essentially the only tool that execs and security specialists think they have at their disposal, and it's completely ineffective in getting development teams to change. Development teams will do the bare minimum checklist of things. It also takes away their agency, so they don't think about it. They just do it to get past something, and that's not what you want. You want them deciding what the right thing is to do and actually doing that wholeheartedly to really get at the problem. They also will hide from, if they know that it's a policy enforcement thing, they'll only show one of their apps to the group, and they'll hide the other apps. And it's a constant chasing around. The security specialist groups say, we find new apps every day that they never told us about. And that's because the development teams don't want to tell them about it because of the approach they're taking. I want development teams to invite me in. I don't want them to turn around and run the other way when they see me in the hallways. And that's key. Okay, so that was tool number 1, is the principles. Tool number 2 is this thing I call the pledge. And this is hard to get security teams to commit to, but I had a lot of help. Nupur Davis, who was with me at the Build Security In initiative at Carnegie Mellon, is now the Chief Information Security Officer. She helped me to sort of get this through the security group. She has about a 400-person team at Comcast working on security. And it took me about 9 months to actually get enough people signed off on this that I could start to say this to our development teams. But if you can get your security group to say this to their development teams, this will go a long way towards breaking down those barriers and building trust. First of all, you recognize that engineering teams want to do the right thing. We trust you to do the right thing. But and you're closer to the business context and will make smart trade-off decisions between security and other risks. So this means that you can validly choose to not do something that the security group thinks you should be doing because you have other concerns that are bigger concerns for your effort at this moment. Sometimes there's bigger business risks than the security risk, and the security folks don't recognize that, but the development team who has to balance all of these are the ones that should make that decision. However, they need information in order to make smart trade-off decisions. So the role of the security team is to provide that information, to basically show them or help them to understand what the risk of this decision actually is. You can decide not to do X, but know that that will expose the company to this type of risk. Are you aware of that? Are you sure you want to make that trade-off, that you think that what you're trading it off in favor of is more valuable than the risk that you're taking here? That's the approach you should be taking. And we also, security specialists, not just need to provide information, but we need to make it really easy. We need to lower the cost or effort size of any of these practices that we're trying to get you to do. Make it dirt dog simple and essentially become less about gating and much more about actually providing the easy button for these security tools and practices. And we want to assist twice as much with these preventative practice changes as we beg for your assistance in reacting to security incidents. And finally, and this is sort of the takeaway from this slide, we recognize we're no longer gatekeepers, but rather we're toolsmiths and advisors, and that is our role as security specialists. If you can get your security specialist team to say this to the developers, you'll go a long way towards earning their trust. So I have this other thing called the trust algorithm, and it's we don't have time to go into it too deeply. We've actually got a blog series going on it at DevSecOpsDays.com. But basically, the idea here is that trust can be optimized, that you can actually learn how to build trust in a formal way. And the formula is credibility, which is how much you know what you're talking about. And to get developers to trust you about development practices, which is what DevSecOps is all about, you have to be a developer. And so a lot of times the security specialist is staffed with very few developers. They need to beef that up, or they need to dedicate a DevSecOps transformation team with essentially all developers on it to gain that credibility. Reliability is, do you do what you say you're going to do? Make sure you track your work. Make sure you get back to teams. Make sure you follow up on their requests or their issues or their problems. Do you show empathy? Do they believe that you understand their other concerns, not just the security concerns? And all of that is divided by apparent self-interest. And there's always a self-interest, so this is never zero. I wouldn't be talking to you. I wouldn't be trying to get you to do something different if there wasn't something in it for me. So the key here is to emphasize the common interest. We both have stock options in this company or RSUs, and we want those to be valuable. We want to see our company stock go up. So if we get in the news for a security incident, that's going to lower our stock value. We don't want that to happen. So that's a good way to sort of take away the apparent self-interest. Oh, we, the security group, want you to do something for us. No, it's we think it's in the best interest of the company for you to do this for all of us, is the way you sort of minimize that apparent self-interest. So this is a 3-part framework. The first part is principles that are agreeable to the people you're trying to change. The second part is making it easy for the people you're trying to change to know what it is they're changing to, and easy for them to do it. And so I use this self-assessment approach to accomplish this. This is a facilitated self-assessment. It takes about 90 minutes, and it changes constantly based upon our capability. We only put things on this self-assessment once we've devised the easy button for doing it, or we only color code it once we've devised the easy button for it. So these gray items are things that we intend to do, but we don't have quite ready yet at Comcast. We don't have a brown belt program launched for our craftsmanship, artisanship training program, or black belt. We have our yellow belt and our green belt programs launched, though. So we allow those to sort of be color coded. So what we do is we sit down with the development team for 90 minutes, and we walk through every cell in this table. And this is an example. This isn't the actual table as we use it right now. It's a subset of it at some point in time in the past. Not too long ago in the past, I updated it, though. So it's pretty close. And the first row, the first cell there is 100% of the group members have been through green belt training, or yellow belt training, sorry. And if that's true, then they color coded green. If it's not true, they color code it red. Or if it's half true, they color code it amber, or some shade of light green or some shade of light red, depending upon how close to accomplishing that they are. And at the end of this, you end up with a table that looks very similar to this at the end of this facilitated session. And the team knows not only what they do well, but what they could be doing, very clearly stated. And behind each of these is details. If you click here, you can have self-sign up for green belt training. And that's the idea, is to make it very self-service, very much easy for them to accomplish the next step in there. So at the end of this 90-minute facilitated self-assessment, we ask the teams, pick 1, 2, maybe 3 amber or red cells that you want to turn green in the next quarter. And we then commit to helping them with their plan. It's their plan. They want to turn these cells green in the next quarter, but we're going to do everything we can to support them on it. If it means we have to go manually add licenses to some tool, if it means we have to get them in contact with a certain person, if we have to set up another meeting, we facilitate all of that just for those 1, 2, or 3 goals they picked. So we don't want them biting off more than they can chew. We just want to get them on the path of continuous improvement. And we come back every quarter and we ask them to update their assessment. How did they do on their plan for the last quarter? Are there any cells that changed colors as a result of that? Are there any new cells that we've added since the last quarter? What's the new plan for the next quarter? And then we'll go back and recommit to them. This usually takes about half an hour is all it takes. And we don't need the whole team for the reassessment. We just need sort of key leadership folks.
Larry, Mark here, just giving you a 5-minute heads up.
Okay, great. We're getting close to the end here. So I'm at a 3-part framework. I'm at part 3, about to start part 3 of that. So pretty good here. The one thing to note about this table is it's not designed to get to the highest security soonest. It's designed to get them on the most gradual adoption curve. So if you look at the way the table is worded, the things on the far left are really easy to do. And they're ordered in the highest priority of the biggest bang for the buck at the top, and then it goes down from there. So they know where to start in the upper left corner of that table and move through it. Okay, so this, part 3 of the 3-part framework is getting management involved. And this is going through some major evolution here now, this visualization, but this is a roll-up of the results of those self-assessments that we are giving to management. We're actually changing this visualization quite a bit. This was a mock-up of an earlier version of it. But for every cell in this table, there's a corresponding cell in the individual team table. And basically, if there's 10 teams in this part of the org, or if there's 100 teams in the whole org, you can roll it up at any level. And this green bar represents, the height of this green bar represents how many of the teams in this part of the org are green for this particular practice. And then the amber represents how many are amber for that. And then the white is how many are some flavor of red. And this plus 6% represents how much they've improved in the last quarter, or the last year, or last reassessment, et cetera. So we're trying to focus execs on improvement by having this plus 6% and practices. Frequently, the execs only get a vulnerability report. That's they just want the red flags. And this is trying to sort of shift their focus away from this. And the way we get them hooked on this is we allow them to set goals here. So we'll recommend we want to get to 100% yellow belt before the end of the year. Do you support that goal? Can we say that that our president supports that goal? And if they say yes, we put a line on this thing, and then we start to tell the teams the expectation is that all teams will get to 100%. So we use management to help sponsor this, to help accomplish it, one cell at a time, or maybe a handful of cells at a time in the table. So there is a tools aspect of this, and I said I would touch on it at the end. We only have a couple minutes left here, so I might not get very far with this, but I do want to show you my overlay of my vision of the tools world from a DevSecOps perspective. The very first, most important, by far the biggest bang for your buck is this tool category called software composition analysis. By some folks, it's also called dependency checkers. It's also called open source security or open source governance. These are tools, and Sonatype Nexus is a great example of that. Firewall and Lifecycle do this kind of analysis. What it's looking for is it's looking for publicly reported vulnerabilities in the dependencies that you're using. 80 to 90% of your applications are these dependencies. The bad guys know that if they find a vulnerability in a dependency that's used by 10,000 products, that's a lot more efficient use of their time than it is to try to specifically attack your custom code. So software composition analysis is an order of magnitude better bang for the buck than any of the traditional security tools that have been out there. One of those tools is static analysis. There's still a place for this. This is still valuable. I still recommend teams do this. This is sort of the next sort of bucket here. And then there's this new category called IAST, which is essentially very similar to static analysis in that it's looking for data that comes from a potentially dangerous source like a user input and gets to a potentially dangerous output like a SQL statement without going through an appropriate sanitizer. It just does that analysis of data flow very differently, does it at runtime by essentially watching how data flows through your app at runtime. Static tries to estimate at it. And the problem with that is that those estimates lead to false positives. So I basically lump these two kinds of tools together into a category I created called primary code analysis. And that is where I expect you to start. I want you to have one tool in software composition analysis and one tool in primary code analysis. And then I'll expect you to layer on more tools as time goes on. There are other tools here, and I've got them grayed out because I know I wouldn't get to them here in this talk, but the two that I start with are those two there, and then the two most important ones here.
Great, thank you.
So I have some recommendations here. They're in the slides for SCA tools and tools in general, and here's how you can reach out to me to get a copy of those slides.
Great, thank you, Larry. In addition to, after the conference is over, we're going to have a G Drive with all of the slide decks in it, so people are going to have access to all the sessions. So that's great. One of the exciting things I saw on there too, Larry, was the start of a maturity model, which I think is going to be critical for helping the whole industry move forward.
Yeah, I'm a little leery about the use of that phrase sometimes, but it is a maturity model. Yeah.
Hey, thank you so much. I appreciate it. I know that you're in a hotel room and you jumped in with us. Very much appreciate it. Thank you.
Thank you. Thank you for having me. Take care.